Algebra 2, Lesson 36, Contrived Problems, Multiplication of Rational Expressions, and Division of Rational Expressions. So, jumping straight to the practice, these problems that you see here that you have to simplify are going to combine a lot of things that we already know. They're going to combine factoring trinomials, factoring greatest common factor out of polynomials, and then rules of fractions as far as multiplication, division, and then cross-cancellation and combining of like terms and all that good stuff. So let's go ahead and get started. Starting with practice A. The first thing we see is that this is a division problem, so we have to immediately invert the denominator. So we're going to go ahead and rewrite our problem, and with the denominator on top, we're going to put x squared minus x minus 72 over x squared minus 5x plus 6. Alright, and then we can turn that into a multiplication symbol. The numerator and the denominator on the left side will remain the same. And our next step is going to be factoring the trinomials, or greatest common factors if there are any. So we'll start here, and I'll just factor above and below each trinomial respectively. So using our rules of factoring, we're going to get an x and an x. Positive means both the signs are the same. Negative means both the signs are negative. Now we have to factor 9. What can go into 9 that will add up to negative 6? Well, if we do 3 and 3, negative 3 will add up to negative 6. So that's x minus 3, x minus 3. That one's done. Let's go to the denominator. X squared gives us x and x. Negative means the signs are opposites. And now we have to find factors of 24 that will add up to positive 5. So if we factor 24, we'll get 6 and 4. That won't work. 3 and 8. That does work. So if we do a minus 3 and a positive 8, that adds up to positive 5. So that one's done. Next one. Both the signs are x. Negative means the signs are opposites. Then we have to factor 72 to where it'll add up to negative 1. Let's see here, 72. We do 6 times 12, but that's definitely not going to work. 8 times 9 will work. So if we do 8 times 9, we could do negative 9, positive 8. Works out, and we're done with that one. Last one. X and x. Positive means both the signs are the same. Negative means both the signs are negative. And then we just have to multiply to 6, but then add up to negative 5. So 2 times 3. Negative 2, negative 3. Okay, we're done rewriting our problem, and then we can start the multiplication process. But before we start multiplying, we want to cancel, reduce, and then cross-cancel. So we'll start with reduction. With these polynomials on top of each other, I can immediately cancel out x minus 3 and x minus 3. Same polynomial, they reduce. Now over here, is there anything I can reduce here? No, I'm not seeing anything. So let's go with cross-cancellation now. If we look across the equation, we see that x minus 3 and x minus 3 will cancel. So this number is now just 1. We look across this way, we see that x plus 8 and x plus 8 cancel. This number is also 1. And that's all we've got left. So then we take 1 times x minus 9, which gives us a numerator of x minus 9, over the denominator of 1 times x minus 2. And that's all we're left with, so that's the final answer. Okay, the second problem is going to be the exact same steps, except the factoring in the beginning is going to be a little bit different, because you'll see we've got a trinomial with a greatest common factor, since the leading coefficient, the leading exponent is not a 2, it's a 3, and then we also have some polynomials that may or may not be able to be factored. So we'll start with rewriting the problem in multiplication. So we're going to invert this term. It becomes x squared minus 7x over x minus 2. Times x squared plus 2x minus 8 over x cubed minus 4x squared minus 21x. So let's start with our odd ones out. This polynomial, it's only x minus 2, cannot be factored at all. This one has a greatest common factor of x. So we'll rewrite this as x parentheses x minus 7. Now this one has the greatest common factor of x as well. So we'll factor out that x, and this is going to become x squared minus 4x minus 21. Okay, now that we've pulled out our greatest common factors, we can go to factoring our trinomials. We'll start with this numerator. X squared gives us x and x. Minus means the signs are positive and negative. And we have to find factors of 8 that will add up to positive 2. If we do 2 and 4, we could do negative 2, positive 4, and that works out. Next, this one. We're going to factor this into x and x give us x. Negative means one's positive, one's negative. So factors of 21 that add up to negative 4, that would be 7 and 3. Negative 7, positive 3. That one's done. And there's nothing else we can factor now. So when you end up doing a lot of stuff like this, sometimes it helps to rewrite the problem so you can see what you're looking at, because we did a lot of work away and it can be really easy to lose track of where we're at. So we'll go ahead and rewrite this really quick. Over here we've got x plus 4, x minus 2, over x parentheses x plus 3, x minus 7 times x parentheses x minus 7 over x minus 2. From here we'll cross cancel and reduce. I don't see any reduction that can happen, so we'll just be cross canceling. 2 and x minus 2, x minus 2, x minus 7, x minus 7, x and x. And all we're left with is x plus 3, or x plus 4 over x plus 3. So that's our final answer. Alright.